Okay, so section 7.3, the addition principle and Venn diagrams. What are we going to be doing in this video? So in this video we'll do a definition of what the addition principle is and some notation. That'll be the first part. And then the second part is examples of Venn diagrams, which is a way to use the addition principle. And we did some of those last time in section 7.2, but we'll do some more examples here. In this section on Venn diagrams, we'll deal with problems 1 through 12, 21 through 25, do examples of those. Note that problems 1 through 12 all deal with the same Venn diagram, so it's sort of, it looks like 12 separate problems, but it's really the same problem over and over again. And then we'll do examples of tables. And that is problems in section 7.3, problems 27 through 31, and 61 and 62. And then we'll do a word problem. And having seen the examples of Venn diagrams, the word problems aren't particularly nasty. And so that's problems 49 through 52, and 57 and 58. Okay. So, let's get started with some definition and notations. From 7.2 on sets, let's just recall some notation. We'll call U is a set. We'll introduce some new notation here actually. N of U, we'll make that a proper U, is the number of things in U. And remember, set is just a collection of objects, and so N of U is just however many objects you've got in your set. A subset of U so this symbol here, sort of a U on its side with an equal sign, that means A is a subset of U. What does it mean to be a subset? Well, everything in A, right? A is a collection of objects. Everything in A is actually taken from U. Or you think of A as just being a part of U, of the set U. But we can also say that N of A is the number of things in our subset A. In A. And likewise, B is a subset of U. Right? And then we can say N of B is the number of things in the subset B. A and B is sort of the standard letters that we use when we're dealing with Venn diagrams. And if we have two sets A and B, we can take A union B. And what's A union B? Well, that's everything in A or in B. Right? So that's everything that's in A or that's in B. Just put A and B together, pile them together. And of course, you can ask yourself, well, how many things is that? So N of A union B, that's the number of things in A union B. And let me emphasize that union goes along with the word or. A intersection B, the upside down U there, that's everything in A and also at the same time in B. Right? So something is in the intersection if it's in both A and B. For something to be in the union of A union B, it has to be either in A or in B, but it doesn't have to be in both. So, and of course we can always ask for N of A intersection B, and the N means number of things in that collection. So this is some notation that we had from sets, and then we have this notation for counting the number of things in each set. And what we want to do with the addition principle is to relate these four numbers N of A intersection B, N of A union B, N of B, and N of A to each other. And perhaps the best way to do that is to look at an example. And perhaps one of the more common examples, and one example that we'll see a lot of throughout Chapter 7 and Chapter 8, is a deck of cards. And cards, you have 4 suits, hearts, diamonds, spades, and clubs. And you have 13 cards in each suit, and those are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king for each one. And this gives us a set of 52 cards in total, divided up in a number of ways. Many of you are familiar with these, with a deck of cards, but we'll just lay it out there so that we all know what we're dealing with. So these are my 4 suits: hearts, diamonds, spades, and clubs. Hearts and diamonds are red cards, spades and clubs are black cards. 13 cards in each suit, 26 red cards, 26 black cards. These cards here, the jack, queen, and king, those are called face cards. The other 10 cards in each suit are called number cards. So the ace is really a number card, not a face card, at least the way this book does it. And so there's our deck of cards. One of the nice things about the deck of cards is that it can be chopped up, split up into so many different subsets. And so U is the entire deck of cards. What does that make N of U? Well, N is the number of cards, so that's 52. And we'll look at 2 subsets. One subset is the suit of hearts. And N of A, well, there are 13 cards that are hearts, right? And so that's N of A. And we'll set B to be the face cards. N of B then, well, there's 12 face cards, 3 in each suit. So, what is A intersection B? Well, that's every card that's a heart and a face card. And how many cards are both hearts and face cards at the same time? Well, just the jack, queen, king of hearts. So this is my set A, this is my set B, we'll call this A, we'll call this B. The overlap, the cards that are in A and also in B, that's my intersection. A union B is hearts, cards that are either hearts or face cards. I shouldn't have that either. Right. So how many cards are those? Well, A union B is all these cards and all these cards. How many cards are there total? Well, I've got 13 hearts, and then an additional 1, 2, 3, 4, 5, 6, 7, 8, 9 face cards. Jack, queen, king of diamonds, spades, and clubs. So N of A union B equals 22. There's 22 cards that are either hearts or face cards. Now you might ask yourself, well, there's 13 hearts and there's 12 face cards. Why aren't there 25 cards in A union B? Well, N of A union B is the 13 hearts plus the 12 face cards. You look at that and say, okay, well, that should be 25, but we've got 22. Why did we get 22? Well, if we count the 13 hearts, we count all of these. That's A. So there's 13 cards there. And if we count all of the face cards, the set B, that's all of these. So what are we doing if we count those? Well, these 3 cards in the overlap, they get counted twice. they get counted once because they're hearts, and they get counted twice because they're face cards. So we have to subtract off that once because we only want to count them once. So we count all the hearts, we count all the face cards, and then we subtract the overlap. -3. That gives me my 22 cards. So the addition principle, that's an example of it, what we just did. N of A union B is N of A plus N of B minus N of A intersection B. If we're looking for all the cards that are either hearts or face cards, you count all the hearts, you count all the face cards, and then you subtract off all the cards that are both hearts and face cards, because you counted them once here and you counted them once there, so you have to subtract them off once. And so that is our addition principle. Okay, so let's move into some examples. And this will cover problems 1 through 12 and 21 through 25. Okay, so in many of these problems what they do is they just give you a bunch of numbers. So suppose you're given N of A is 14, N of B is 32, N of A union B is 39, and N of U equals 100. And you're told to construct the associated Venn diagram. That's the first part of the problem. And the second part of the problem is find N of A prime intersection B, N of B prime, N of A intersection B prime, and N of A union B prime. So find those three numbers. Okay, so if you're given all this stuff, what do you need to do with it? Well, first we build a Venn diagram, and the Venn diagram always starts out looking the same. It's a box, and that represents our set U with two circles in the box. The left one is A, the right one is B. And so there's 4 regions, 1, 2, 3, 4, and you need to find out how many things are in each region. Now we can't just start putting in these numbers because we know N of A equals 14, but A's got 2 parts to it. How many is here? How many is here? It could be 10 and 4, it could be 7 and 7, it could be 1 and 13, we just don't know at this point. N of B, that's 32, and again we don't know how that's split up. N of U, well, U has got 4 regions, right? Everything inside the box. And that's 100 total, but we don't know how that's split up. And the goal is to be able to figure out how much is in each of these 4 regions. This region here, this one, this is the overlap between A and B. And what we know from the addition principle, if we know N of A union B, N of A, and N of B, then we can figure out N of A intersection B. So how can we figure out what numbers go where? In this case, we'll start with the addition principle. Which is N of A union B equals N of A plus N of B minus N of A intersection B. We know what this number is, that's 39. We know what this number is, that's 14. We know what this number is, that's 32. And we don't know what that is. So A union B is these 3 spaces. We know there's 39 in those 3. We know there's 14 in these 2, 32 in these 2. So how much is in that one? Well, we can move this over to the left side, this over to the right side. N of A intersection B is, this is 46 minus 39. That equals 7. So we know there's 7 there. But once we know that, we know a lot more, right? 7 here means that there's got to be 7 here. because the total in A has to be 14, so 7 and 7. Total in B has to be 32, so 7 here means there must be 25 here. And for the outside of the two circles, we do know that A union B, that's these three together, that's 39. And we know that total, there's 100. So if 39 is in here, then 61 must be out there. And so now we filled out our diagram. And now we have to figure out what these three are. N of A prime intersection B. What's that? That's the number of things, because that's what the N stands for, number, not in A. Not is the prime. Intersection is and in B. So everything that's not in A and is in B. So in B means that you're one of these two regions, either this one or this one. Not in A means you're outside of A, so that means this region or this region. So what's the region that's not in A and is in B? Well, that's only here. Right? It's inside the circle for B, it's outside the circle for A. So N of A prime intersection B equals 25. N of A intersection B prime, same deal. This is the number of things in A and, because it's an intersection, not in B. Right? And is intersection. The prime means not. So in A means one of these two regions. Not in B. Well, this is a circle for B. Not in B is one of these two regions. What's the region that's in A and not in B? That's that. So N of A intersection B prime equals 7, because we're talking about this region. And the last thing we want to know is, what's N of A union B prime? And you have to identify what regions we're talking about. Again, N means number of things in A, because there's no prime there, or, because it's a union, not in B. So, number of things in A, that's this. That's 14 things are in A, or not in B. How many things are not in B? Well, there's this 61 that's not in B, and there's this 7 that's also not in B. But we don't want to count this 7 twice, right? It's in A, and it's also not in B. So it's 7 plus 7 plus 61, 75 things. So 75 things that are not in, are the number of things that's in A or not in B. That's all this region. Okay, and so for a lot of the problems in 1 through 12, they're very much like this, right? Figure out which region you're talking about, like this problem or this problem or this problem. They give you a region, you just sort of have to figure it out which region it is and say what number it is. 21 through 25 are much more like this statement, where they give you the numbers and you have to construct the Venn diagram. So another example along this lines of constructing a Venn diagram is, suppose you're given N of A prime equals 63, N of B prime equals 81, N of A union B equals 49, N of U equals 100. And then fill out the Venn diagram, semicolon, and find, say, N of A prime intersection B. Okay, so a useful trick that I use for Venn diagrams, I don't know if it's a trick, but it's just a useful way for me to think about it, is to look at this and say, well, here's my set U, here's my set A, here's my set B. I've got 4 regions I have to deal with. I have to find out what number goes here, what number goes here, what number goes here, what number goes here. So I'm going to call this one region 1, region 2, region 3, and that's region 4. And those 4 regions I have to fill out what numbers go where. So A prime is the regions outside of the circle for A. So that's 3 and 4. So region 3 union region 4, that gives me A prime. N of A prime is 63. So 3 and 4, that's got 63 things in it. B prime is everything outside the circle of B. So 1 and 4. Region 1 union region 4. And the number of things in B prime is 81. A union B is what? Well, that's everything that's in A or in B. So it's region 1, 2, and 3. That's everything that's inside of the two circles. And how many things are in there? We know there's 49. And U, well, U is everything. Region 1, 2, 3, and 4. And we know there's 100 things there. So we need to figure out what numbers go in which region. So I'll redraw the Venn diagram. There's U, there's A, there's B, and we'll leave everything blank so we can fill things in. Looking at this, we know that 1, 2, and 3 together has 49 things. We know 1, 2, 3, and 4 together, that's all of U, that's got 100 things. So region 4 has 100 minus 49 equals 51 things in it. Because if I've got 100 in everything and 49 here, well then there must be 51 here. So there's 51 out there. So that's useful. But once I know that, right, I know there's 51 things in region 4. In regions 3 and 4 together, there's 63. So region 3, right, together with region 4 has 63. So region 3 must have 63 minus 51, 12 things in it. Right? This region plus this region, 3 and 4, that must have 63, but that one's got 51, so that one's got 12. Likewise, regions 1 and 4 have 81 things in it. So regions 1 and 4 have 81 total, but we know there's 51 in region 4, so region 1 has 81 minus 51 things in it. 30. Great. Now we're pretty much done, right? A union B is regions 1, 2, and 3. 1, 2, and 3. And we know there's 49 total in these three. We know there's 42 in these two, so there must be 7 there. So region 2 has 49 minus region 3 and 1, 7 things in it. Great. And so that, for me, is one way to deal with all these primes, is think about them in terms of these 4 regions. A prime is everything outside of A, so that's these two. B prime is everything outside of B, so that's these two, etc. A prime intersection B. A prime is everything outside of A, so that's these two regions. B is everything inside of B, so that's these two regions. What's the overlap? Because we're looking with AND. That's just this region. This is in A prime because it's outside of A, and it's in B because it's inside of B. So this actually equals 12. Okay, so there's our Venn diagrams. So the Venn diagrams problems aren't too hard. They're little puzzles where you have to sort of fill out those 4 regions. Another way to do these problems is to do tables. And so we get the same kind of thing that are given as tables. It's problems 27 through 31, 61 and 62. So suppose you're given N of A is 60, N of B is 54, N of A prime union B prime is 58, and of U equals 100. And you're asked to fill out the table. In the book, when you do these problems, they give you an example of what the table should look like. It's got 3 columns and 3 rows. 1, 2, 3, 4. And one column is A and A prime and totals, B and B prime and totals. So, if we think about the Venn diagram in terms of this table, this is A, this is B, this is U. This square is everything that's in A and in B. This is A intersection B, that corresponds to this. This is everything that's in B but not in A, so that's this. So these two together are these two, and the total is however much stuff is in B. This column is everything that's in A, right? So the set A has 2 parts, A intersection B, that's this, and A intersection B prime, everything in A that's not in B, that's there. So that's that, and this is the total in A. Likewise, A prime has 2 parts, right? A prime is everything outside of A, that's this region and this region. So A prime can be divided up into the stuff that's in B, that's here, and the stuff that's not in B, that's out there. And that's the total amount in A prime. So we can start filling out the table. Number of things in A, well, that's this column, so there's 60 here. Number of things in B, well, that's this row, so there's 54 there. How many things do we have total? We have 100. So going down this way has to add up to 100. Going across this way has to add up into 100. So there's 60 things in A, so there must be 40 things not in A. There are 54 things in B, so there must be 46 things not in B. Okay. And now we have to use the rest of these to be able to get one of these numbers. If I can get one of these numbers, then we're good to go. But what do we now have? We know how many things are not in B. We know how many things are not in A. We know how many things are in the union of A prime, union B prime. So we can pull out our addition principle again. How many things are in the union of A prime and B prime? Well, that would be the number of things in A prime plus the number of things in B prime minus the number of things in the intersection. And what's the intersection of that? And that's this number. A prime intersection B prime, that's everything that's not in A and not in B. That's this number that we're looking for. But we know what this number is. That's 58. How many things are not in A? That's 40. How many things are not in B? That's 46. So we'll bring this over to this side. 86 minus 58. So 86 minus 58 is 18. No, that'll be 76. 28. There we go. So there must be 28 things here. Great. Well, if we know these two numbers add up to 40, then this must be 12. And if these two numbers add up to 46, then this must be an 18. If these two numbers add up to 60, and this is 18, then this must be 42. And as a check, these two numbers should add up to 54, which they do. So, what are the regions here? There's 4 numbers. There's 1, 2, 3, 4 regions. A intersection B, that's 42. A prime intersection B, that's everything that's in B but not in A, so that's my 12. And no, 54 total in B. This region is everything that's in A and not in B, so that's this element of the column, everything in A but not in B, so that's 18. And then this region out here, that's everything that's not in A and not in B, so that's 46, and so that fills out the Venn diagram. So you can fill out the table. It's another way of looking at a Venn diagram. In a Venn diagram, you have to fill out these 4 regions. in the table, you have to fill out these 4 entries. And that's problems, what's that? That should be 27. 27 through 31 and 61 and 62 are looking at these tables and reading them a little bit. And finally, word problems. Well, now that we know how to construct and deal with Venn diagrams, word problems aren't particularly nasty. You just have to figure out what the various regions in your Venn diagram are. So we'll do an example. Oops, it's a 59. So these are problems 49 through 52 and 58 and 59 in section 7.3. So suppose there are 75 students, of whom 42 are taking Math 196, and 38 are taking Philosophy 194, and 22 are taking both. How many are taking neither? That's certainly one question you can ask. Another one is how many are taking 196 but not 194? Well, there's a couple ways to do this. You can do this as a table, or you can do it as a Venn diagram. We'll set up the Venn diagram here. U, and of course 2 sets, A and B. So U is my collection of all 75 students. We'll say A is the students taking Math 196. How many of that are there? 42. B are those students taking 194. How many of that are there? 38. And then the 22, well, those are taking 196 and 194. So the and tells you that must be A intersection B. And there's 22 of those. Great. So there's 75 students total, 42 in A, 38 in B, 22 in A intersection B. Now that's the overlap between A and B, so there must be 22 in there. Once you know that one, and that there's 38 in B, well, this plus this must be 38. So 38 minus 22, 16 in that one. How many are in A? Well, there's 42 total in these two, but there's 22 there. If there's 42 total, there must be 20 in there. Great. So N of A union B, that's this plus this plus this. That's 42 plus 16 is 58. So we've accounted for 58 of my 75 students as taking 194 or 196. So there must be 17 taking neither one, and that's that batch. So how many are taking neither? 17. How many are taking 196 but not 194? Well, A is the group of students who are taking 196. That's everybody here. This 22 are taking both 196 and 194. This 20 are taking 196 but not 194. So 20. And this here is actually N of A intersection B prime. And that gives you that. Okay, so that's section 7.3, word addition principle and Venn diagrams. There's another section to 7.3 which is about multiplication principle and tree diagrams, and that'll be in a different video. But having gone through this video, you should be able to do all the addition principle problems and all